Alright students, welcome to the next lesson of your number patterns. This lesson we're covering chapter 8D, recurrence relations for arithmetic sequences. So recurrence relations for your arithmetic sequences. Last lesson we looked into what an arithmetic sequence was. So remember, it's basically a list of numbers. So remember, a sequence is a list of numbers, but an arithmetic sequence is a list of numbers where each term is generated by adding or subtracting by the same number. So basically the difference between each number is the same. And you can see in this pattern 5, 12, 19, 26, 33. It's going up by 7, 87, 84, 81, 78, 75. It's going down by 3. So it's going down by the same amount, meaning that those are arithmetic sequences. We also learned about the common difference, which is the amount that it's being subtracted or being added. So basically, common differences are related to your arithmetic sequences, and they are the amount that you're either adding or subtracting by. So if you've forgotten how to calculate your common difference, make sure you just read or go over the previous notes, which is what I'm showing you now, because it will help with this exercise and this chapter for 8D, your recurrent relations. So our learning intention today is to understand the concept of recurrence relations for arithmetic sequences. So what a recurrence relation is and how it relates to your arithmetic sequences. And as our success criteria, you'll be able to interpret and apply what a recurrence relation is for your arithmetic sequences and also construct a recurrence relation from a sequence, just with arithmetic sequences. So basically, a recurrence relation is a set of instructions, as it says here, that will tell you how to generate the next term of a sequence. So it's instructions, if you think about it, that will tell you how to generate or tell you how to get the next term of a sequence. And they look basically like this. So this here is a recurrence relation. Okay, and it's a set of instructions that tell you two things. Okay, the first thing is that the recurrence relation tells you what's the first term. First term is normally denoted by the letter A. So when we say A, it's referring to the first term. The second thing it talks about is the common difference. So the common difference will tell you how much you need to add or subtract to get the next term. Okay, so those are two things that a recurrence relation tells you. What's the first term? So it's basically this part of the instruction. And then what's the common difference, which is this part of the instruction. So there's two parts, okay, that you need to know for any recurrence relation. So let's use that in an example. So here we need to generate the first 5 terms that is modeled by this recurrence relation. So in this recurrence relation, it shows that T1, remember, is the first term, is 5. So 5 is the first number. And then to generate the next term, so some of you guys asked in the previous lesson, what does this Tn plus 1 mean? It just basically means the next term. Okay, Tn is referring to term number. Plus 1 obviously means plus 1. So if for example, you have T3 plus 1, that means you're looking for term number 4. If it's T2 plus 1, then you're looking for term number 3. Okay, so in this case, this is saying to get the next term, it's going to be the current term plus 2. That means the common difference is 2. So let's use that in example here. So let's generate the first 5 terms. So term number 1, we already know is going to be 5. That's easy. Term number 2. So let's use the recurrence relation. Having a look at the recurrence relation, okay, it's a Tn plus 1 equals Tn plus 2, meaning the common difference is 2. Now, if I write this the long way around, this whole thing in the working out here, it would be T1 plus 1 equals T1 plus 2. Okay, T1 plus 1 equals T1 plus 2. So that what this becomes is T2 is equal to T1 plus 2. Okay, that's what that's saying. So in this case, T2 would be, term number 2 would be term 1, which is 5, right there, plus 2. And that equals, how should I put it here? Term 2 equals 7. Now, technically, you don't need to add this step here, so I'm going to get rid of it so that it doesn't confuse anybody. All right, so I'll write all this again. All you really need to put in is that term number 2. So remember, this recurrence relation tells you how to get the next term. So that means term 2 will be equal to term 1 plus 2, which equals 5 plus 2. So term 2 is 7. Term 3, so let's do that. Term 3 will be equal to term 2 plus 2, which is your common difference. So term 3 is equal to 7 plus 2, which equals 9. Term 4, okay, and you can probably see the pattern here, is equal to term 3 plus 2. So term 4 would be 9 plus 2, which means that term 4 is 11. And then term 5 would be term 4 plus 2. So term 5 is equal to 11 plus 2, which means term number 5 is 13. So that's how we generate our sequence. Now you might be tempted to just write down the numbers 5, 7, 9, 11, and 13, but you need to show the working out for it. And this is how you show it. Okay, you must show the working out in this manner. Okay, let's keep going. Another example, generate the AND graph. Now we've got 2 parts here, so we need to generate the first 5 terms in this sequence and then graph it. Okay, so let's look at this sequence, this recurrence relation. Term 1 is 3, so that means T1, first term is 3, and the common difference is plus 1.5. So this, to get the next term, is going to be the current term plus 1.5. So let's list out the first 5 terms here. So T1 is 3, that's easy. Actually, let's go here. T2 would be T1 plus 3, plus 1.5. So that would be 3 plus 1.5. That means T2 is equal to 4.5. Alright, T3 would be T2 plus 1.5. That means term 3 is equal to 4.5 plus 1.5. And that would equal 6. Term 4 would be term 3 plus 1.5. And that would be 6 plus 1.5, which means T4 is equal to 7.5. And last one, term 5 is equal to term 4 plus 1.5. Term 5 is therefore 7.5 plus 1.5, which means that term 5 is equal to, oops, let me fix that up. Term 5 is equal to 9. Now we graph this. All right, so in the previous lesson I showed you how to graph an arithmetic sequence from a X and Y table. This is going to be similar. So on our X-axis, you're going to have the term number, so n, and then on the Y-axis, term value, tn. So you're just going to graph the first 5 numbers. 1, 2, 3, 4, 5. 4, 5. Let me fix that 4. Okay. And looking at my values, it starts at 3, finishes at 9. I might go up by 2s. So 2, 4, 6, 8, 10. Now we graph it. Term number 1 is going to be 3. So term 1, 3. So 3 is here. Term number 2 is 4.5. So if that's 4, that's 5.5 should be about here. Term number 3 is 6. So that will be here. Term number 4, 7.5. So if that's 7 right here, 0.5 would be a bit higher than the middle between 6 and 8. And then term 5 is 9. So that's here. And there is the graph for our arithmetic sequence from this recurrence relation. Alright, let's try this example here, where we need to calculate the value of the 10th term in the sequence. Now, in order to do this question, obviously you need to know what's the recurrence relation saying. So that's term 1, which equals 3. And to get the next term, we're going to add 1.5. I believe it's the same example as the previous one. And we already got up to term 5. Okay, so we now need to get from term 5 to term 9. Okay, so working that out recursively, this is what that means to work this out by hand. Okay, is to use that working out that I showed you. So term 5 we know is 9. Alright, so we need to go from there and work out what term 10 is. So term 5 is 9, term number 6 should be term number 5 plus 1.5. Now, I'm going to skip this step now and just go straight to what term number 5 is, which is 9. Okay, and that will sort of make it a lot quicker to do these questions. So term number 6 should be 10.5. Okay, term number 7 would be term number 6, which is 10.5 plus 1.5. So term number 7 should be 12. Term number 8 will be 12, which is what term 7 was, plus 1.5, and that should equal 13.5. And lastly, term number 9 will be 13.5 plus the 1.5, which is the common difference. Remember, that's where we get the common difference here in our recurrence relation. So that will equal 15. So term number 9 is 15. Oh, sorry, we're looking for term number 10. I thought we were going to finish at 9. So term number 10, sorry, just make some space. Term number 10 will be 15, which is what term 9 was plus 1.5, which is your common difference. Therefore, term 10 is 16.5. And that's how we work out a value recursively. Now, again, this can actually be done on your calculator. Okay, I might do this really quickly, actually, just so you have a reference to it. And also, this will, if you started that calculator task yesterday, this is how it's expecting you to work it out. So what you do is on your calculator, obviously turn it on, press the first number, term 1, which is 3, and then press enter. Make a note that that's term 1. And then after that, look at the common difference, or look at the recurrence relation to figure out what you need to do to get the next term. So in this case, it's plus 1.5. So on my calculator, after you've pressed equals, press plus, and it'll be ANS, refers to whatever the previous term was, plus the common difference, which is 1.5. So if you press enter, that'll give you term number 2. So we can make reference to that here. Actually, that's the previous one here. Term number 2 there, which is 4.5. Term number 3 was 6. Term number 4, 7.5. And term number 5 was 9. So keep going here. Term number 6 was, where were we? Yep, 10.5. Term number 7 was 12. Term number 8, 13.5. Number 9, oops, is 15. And number 10 should be 16.5. And if you keep pressing enter, you get whatever term that you're looking for. Okay, so that's how we use it on our calculator. All right, last one is, the last part of this is learning how to create a recurrence relation. So remember, when we create a recurrence relation, you need to state, oops, sorry guys, you need to state the first term. Okay, so as it says here, state the first term and then specify the common difference. Those are two things you need to write. Remember, your recurrence relation has two parts to the formula, or to the instruction. You've got the first term and then you've got the common difference. Okay, so let me make that even clearer. So you have to write down the first term and then write down the common difference. Those are the two parts of the recurrence relation, and it has to look like this. Okay, so let's do an example here. Create a recurrence relation that models this sequence. So remember, your recurrence relation should state T1 equals, so T1, remember, actually, let me write the formula down, or the form of the question, recurrence relation. So it should be T1 equals A, which is the first term, separated by a comma, Tn plus 1 is equal to Tn plus common difference. So in my formula, we need to write down what is A, okay, for first term, and what is the common difference. And we'll leave that blank, whether it's plus or minus. All right, so those are the two things you need to write down. A, which is your common difference, your first term, and D, which is your common difference. So looking at my recurrence relation already, I can tell that the first term is going to be 500. All right, right there, T1, 500. So write that down. So it's going to be T1 equals 500. That's the first thing you need to write down. The second thing you need to write down is the common difference right here. So how do we figure out the common difference? Remember, the formula for common difference was any term take away or minus the previous term. Now, we learned this in the previous lesson or the previous video. So go ahead and watch that if you forgot how to do this. But it's any term minus the previous term. So I'm going to use any term here. I'll go T2 or T3, take away T2. Okay, so in this case, the common difference would be 550, take away 525, which equals 25. So the common difference is, it's a positive 25, so plus 25. There's my common difference. There's my recurrence relation. It's that easy. Let's do one more example so that we can really get it. I'll make my own sequence here. Let's go with 20, 17, 14, 11, 8. Okay, so this is T1, T2, T3, T4, and T5. So let's make my recurrence relation for this. Remember, your recurrence relation has to look like this. Okay, so that means here, it's going to have to be T1 equals, what's my first term? Tn plus 1 equals Tn, and then what's the common difference? Those are the two things you need to write. So first term, common difference. All right, so let's look at my recurrence relation. I can already see my recurrence relation, first term is 20. So let's write that down, 20. Sorry guys. 20. All right, and my common difference. All right, how do I calculate my common difference? Remember, any term minus the previous term. So I might go T5 take away T4, which will be 8 take away 11, which equals negative 3. So my common difference is minus 3. And there's my recurrence relation. So remember, your recurrence relation should look like this. Okay. So go ahead and do the exercises for 8D. Questions are attached in your team's assignment. If you need any help or if you have any questions, I'll be available. But yeah, make sure you do all the questions. Thank you.